My name is Ken Peppel. I'm going to be talking today about moving beyond just simple installation of your OpenStack cloud and how actually you'll help manage your cloud as it moves into pilot and then production. Yasmina will have sent out the presentation, or at least a link to the presentation. The presentation that you can pull down from the website, and if you didn't get the link, I will give you the link at the end here, actually has a few extra slides in it. We were concerned we wouldn't make it through the full hour with all the slides. So you will want to go look at those. It does have a few extra slides, especially in detail sections there. So with that, I've already been introduced, but just to say I've been contributing code to OpenStack since the bear release way back in 2011. I wrote some of the early features around flavors and things like that. But most of what actually I do today is I actually help customers with either implementing, architecting, and managing their cloud. We came to this experience by having run OpenStack at Internap, one of the early OpenStack public clouds, back when there really were very, very few tools and when actually it was very difficult to actually simply do the installation and keep it running. Today, we've taken many of those tools and hopefully have contributed those to some of the best practices. So let's talk about the problem first. Today, when you talk about OpenStack and you see it in the press, you talk to most of your friends about it, really installation of OpenStack gets all the attention. However, I think what we've seen over the past 2 to 3 releases is that is getting easier and easier. You've seen both the code mature as well as distributions emerge, like Red Hat's OSP or their RDO distribution, some smaller startups like Cloud Scaling and Piston. But you've seen a number of different companies attacking this installation issue. And here's my bet, we're going to beat that. I don't think we're exactly there yet. It still is probably a little bit more difficult than it needs to be to install, but this will be a solved problem very soon. And then really the question becomes, then what? The reality is we should be looking at how we're going to manage OpenStack and actually provide the level of service to our customers. As bad as installation can be sometimes, and it can be confusing for many people, installation is really 2 to 3 weeks of your overall life cycle for an OpenStack cloud. And this is what I learned when I ran OpenStack's public. I ran Internap's public cloud, which is there were 2 to 3 weeks of installing it. There was then 18 months to 2 years of actually running that cloud. And that's really where you need to focus a lot of your time on. That management really is forever. And if we look at the OpenStack architecture here, you can see it's a much more distributed problem than we're probably used to, especially from the enterprise. The picture here shows all the processes, their interactions, and the APIs within OpenStack Icehouse. And as you can see, there are many interdependencies. There are a huge number of different processes, and many of them actually depend on each other. This is unlike many of the applications you may be used to in the enterprise, which may have, a simple 3-tier application with an app server that depends on a web server that depends on an app server, and then the app server depends on the database. Here you can see there's actually multiple dependencies and a huge number of processes. So unlike our other problems in the past that we may have been able to handle fairly well with traditional monitoring, this is really a new problem domain for many of the enterprises out there. The other problem that you'll see is that just of scale and size. Even fairly small OpenStack clouds can be dozens to hundreds of machines. And with that scale comes a whole host of new issues and require us to look at different tools and different ways to monitor. And so within this presentation, what I'm going to talk about is some basics about what we need to have in place to really be effective in managing OpenStack. And then I'm going to dive into different sets of tools and metrics that you should be looking at as you start to manage your cloud. Now, this is an exhaustive list. We only have an hour today. But I do hope to highlight some of the major points and some of the major areas that you should be looking at. So let's start with the basics. So there are some things that I'm just going to assume that are a given for you, and it's going to be very, very difficult to manage your cloud without them. And so first and foremost, you really need to have a development and test cluster. Now, ideally, you're going to have a development and test cluster. You're going to have a staging cluster. You're going to have actually a production cluster or cloud. But at the very least, we need to have another cloud that's smaller but representative with the same set of versions of software and the same set of services in them. We really need that because we're not going to be able to test and do management on the cloud directly live. Many of the things that you will find within using OpenStack is there are heavy dependencies and kind of unknown consequences by changing some variables within configuration files, and they may ripple through to other parts of your application or your cloud, and it may be very difficult to figure out what's actually gone wrong and where actually things are going wrong. So it's imperative that we have a development and test cluster where we can reproduce problems that we see within the production cloud. We can test fixes, as well as practice any kind of upgrades or any kind of other major events on your cloud. I'm also going to assume that you have some kind of configuration management system. Now, I don't really care which management system that you use. There are many very good systems out there, Chef, Puppet, Ansible, SaltStack. I'm sure I'm leaving out many of them. And I'm not here to campaign for any particular one. I would just say that in general, your OpenStack distribution probably already uses one. For example, RDO uses Puppet. The Mirantis ones use Chef. Most of them use one or the other there. If you already have a distribution and it's already using Puppet or Chef, I would go ahead and pick that and stick with it. However, it doesn't mean that it has to be that way. I think the most important thing here is that you're actually using a configuration management system and that you stick with it. Everything falls underneath it. You do changes through there. And also, you make sure that all of your systems actually fall underneath that. Almost every time we had an outage or something strange within our public cloud and internet, it could be traced back to some system was taken out of configuration management for some reason or another, and we made some change on it, and inevitably that change was incorrect and wasn't being updated. And so make sure that there's a configuration management system, make sure that you're using it. And then the last thing is there does need to be a skilled and trained staff. Many of the concepts within OpenStack are somewhat advanced, even for Linux admins with decent virtualization skills. So you do need to have those experienced Linux admins. You do need to have at least access to one or two network architects that understand cloud and understand virtualized networking. It's very difficult to find all of these skills within one person, and so it does take a team to be able to do this. And it does take some level of training for OpenStack. Many of the people are coming from a VMware background, which is similar and certainly has many of the core or key skills there. But there are some differences in how cloud and how OpenStack works. And without that training in OpenStack, it's going to be very difficult for them to make the leap from virtualization to cloud. And so with those basics in mind, let's look into what kind of tools that we can put together to help you manage your OpenStack cloud. I basically put the tools into 3 or 4 categories. So I want to have a set of troubleshooting tools, and those tools are going to help me when I actually have an incident or a problem to be able to resolve that problem by isolating where I actually have the problem and then helping me see how I can fix it. And so in general, there's 2 sets of those tools that we'll use. Some of them are operating system level tools, and some of them are OpenStack specific tools. I'm also going to have a number of administration tools to be able to do your basic system administration things, whether they're from the very simplest of things like adding users and changing passwords, to being able to perhaps go in and actually fix things which may have gone wrong. For example, if an instance failed to boot, being able to reset it to a place where I can actually delete it out so that we can reclaim those resources. And then finally, where we'll spend most of our time today is monitoring tools. Is how am I actually going to monitor this so I know when there's a problem and know when I can actually go in and tell people that everything's running all right. And so here we're going to look at monitoring platforms as well as some log management tools. And we'll talk about the importance of those in the coming slides. So let's start with troubleshooting tools. These tools are used to investigate or fix problems within your stack. In general, they're mostly Linux tools, but there are some specific to OpenStack. And we will use many of the Linux tools in a different way to investigate our OpenStack deployment. And these tools tend to span virtualization, networking, and some of your normal sysadmin tools. In general, they tend to be tools that you probably haven't used before, or you're using them in a different way. So for example, let's talk about troubleshooting the hypervisor. Now, every one of your hypervisors out there are going to have their own proprietary tool chain. However, we'll talk about the most common ones, which are built in with KVM, which tends to be the most popular hypervisor to use with OpenStack. And so, for example, one of the big points here is how do you actually map VMs to where they're located? Now, this is kind of a key point for many people. Just being able to find out if I have a problem with the VM, how can I actually find out which host it's on so that I can actually go in and use normal virtualization tools to figure out what the problem might be. We'll also look at how we might be able to access some of the backing store through the hypervisor mounts to see if I may have problems which may lie deeper into the actual boot volumes and such like that. And so, for example, here's a troubleshooting kind of path that we've done, trying to figure out if we can see actually through to the virtualization level where our VM actually is. And while this picture is fairly small, and I apologize for the small type here, if you get the slides, you should be able to see this hopefully at a higher resolution. But Nova List, which is the Nova command line tool, will actually show us a list of our running or any active state instances which are on our cloud. Once we go in with Nova Show, we can actually pull metadata about a particular instance. So I've given it the command Nova Show and then the instance ID. That instance ID, if I'm running this as a privileged user or an admin, will actually give me an extended set of metadata. And the most important one there is where it says hypervisor _ host name. That's actually going to tell me what actual computer or host it's actually residing on. Once I've found that, I can simply SSH into that particular machine. And from there, really what we're looking at is a simple KVM server. So you should be able to go in with Virsh, which is the virtualization shell. And the first thing to do then is to look at Virsh list. And what I should see is something that has the same name as my instance name. So this one's instance 0000E. I should see something like that running. And that instance name will match what I see up in the metadata. That is my particular instance, and now I can go in and use any of the virtualization shell tools that I might want to use. So for example, if it has TTYs or PTYs connected to it, I can do a Virsh console and go directly into that via the virtualization shell, and I can get low-level access to it with all those KVM tools. Now, I have other options for that. Obviously, within OpenStack, I can get into a console or I can pull the logs through the normal commands, things like Nova console get or Nova console log, and they'll actually pull those logs for me. But sometimes I can't actually get to that because of some error or some other reason. Through this, I can actually get to the normal virtualization shell, and I can use all those normal tools. So if I have to, I can use a KVM snapshots or any of those kind of tools to be able to pull a version off and then go troubleshoot it on a different machine. And so that's kind of a simple way that we might be able to do some VM troubleshooting. Obviously, there's more tools there, but this gives you a simple path to get down to the actual VM on the machine. Now, more often, you'll tend to have networking problems. I would say today, somewhere around 50% of the problems or more that people tend to have with OpenStack or clouds in general tend to be with networking. So networking really takes a combination of Linux tools, Linux networking tools, Open vSwitch tools, as well as OpenStack tools. And I think this tends to be where what trips up most people out there is they actually don't know which level or which tool set they should be looking at to find their problem. OpenStack tools will show the logical configuration of Neutron's ports, routers, and subnets. Neutron is OpenStack's networking component, and it controls very highest level, where the actual cloud level of how things plug into other things, how layer 3 router or networks are connected, and how subnets and networks work. Within here, you're going to see tools like Neutron port list, where I'll be able to list all the interfaces, which I actually see within Neutron, and be able to isolate those down to a particular user. I'm going to show Neutron net list, show all the networks that have been created, both provider networks, networks created by the cloud operator, as well as networks which may be created by a tenant. And I'll be able to see all of those in there. And then finally, and this is where most of the connectivity comes in, I'll be able to see a router list. And the router list actually allows you to connect tenant networks to the provider networks to get out to the internet, which tends to be one of the most common issues that people have. Neutron, though, is only showing you the constructs built in the cloud, though. It's not showing you underneath what's actually providing that for you. And to do that, you really need to look at two different sets of tools. So one of them is Open vSwitch. Open vSwitch is the actual switch provider that will run on your both compute nodes as well as network nodes, and it helps you map internal and external bridges. And so the most important command there that we tend to use is what's called OVS-VSCTL, or visualization control. It will actually show you all of the bridges on your particular server, and will actually show you what interfaces actually reside on each bridge. Now, the interfaces will be matched up to the ports within Neutron, and you can actually do a mapping of the Neutron port list to OVS's bridge list and find out which interfaces are on which bridges. In addition, there are a number of Linux tools, and we'll show you how to use one of the Linux tools here on the next slide. But these actually allow you to get inside the VLANs and Linux namespaces that are used heavily within Neutron, and allows you to do some troubleshooting as well as identify some of the configurations there. Now, these tools have existed obviously on Linux for quite a while, but some of them are somewhat new in how people will use them. So things like IP tables and TCP dump are obviously standard networking tools. However, IPNetNS, which is IP net namespaces, is new to a lot of customers out there. And in general, this is where we run into the problems, especially when people are running with Neutron's networking, running either VLAN or GRE tunneling mode. And so if we look at actually trying to do some troubleshooting here, this is how we can actually use some of these tools to do that. Now, one of the common problems I tend to see customers have is that they've set up their own tenant network. They want to connect it to the external network so that VM can actually get out and view the things on the internet. But for some reason, they're not getting connectivity. And so one of the first things I do is go in and troubleshoot their router. On the right-hand side here, you're going to see a picture. That picture is actually from Horizon, and it's showing you the network topology that you've built. And as you hover over any of those pieces, for example, I'm hovering over the router right now on that picture, you'll see the interfaces on that router as well as the UUID of the router itself. And so the first thing I'll do is go look and find out where in the namespace is that router. And so the top command there, you'll see I'm using IPNetNS show. That's going to show all of my network namespaces. You're going to see a large list here, basically adding up to 1 to 2 namespaces for every single network that you have created, plus every router that you have created. The key here is the UUID of your router is loaded into the network namespace name. So if you look at Q router, the numbers behind that, E43, and going on from there, you'll actually see that's actually the UUID of the router that we're looking for. And once I have that, I can actually look inside that namespace to find out how that router is actually been configured. Now, you will see under the IPNet show, you will also see a bunch of DHCP or QDHCPs. Each one of those correspond to the DHCP that you've actually created when you created your subnet within Neutron. And you can also look into those if you're having some kind of problems with actually getting an IP address for your instance. In this particular example, though, I'm going to go in and look at the router to make sure the interfaces are correct. And so I use another variation on the IPNetNS command, which is IPNetNS exec. I then give it the namespace, which is the Q router namespace I looked at above. And then I give it a particular command of what I want to look inside there for. In this particular one, I'm doing ifconfig just to look at the two interfaces. And here, what I'm hoping to see is the interface of both of these interfaces are going to match the two interfaces that actually Horizon is showing me or Neutron is showing me through the command line. Now, most of the times you'll find those are correct, but occasionally you may find that for some reason one of those interfaces is not correct. And then the easiest thing to do there is actually deleting that router and recreating it. But this will actually make sure that both what Neutron thinks the router is configured as, your actual Linux box thinks the same configuration for that router. The final command down there is simply to look at the routing tables within that router or namespace. So I've done the same command there, but instead of giving it an ifconfig, I've actually given it a netstat -nr. So just the normal Linux command to show me the routing tables. And I should see a very clean routing table, which just has two routes for it. One going to one network, one going to the other network, with the correct interfaces there. So as you can see here, with three simple commands, I've been able to go through and verify that Neutron's configuration of my router and the Linux box actually have the same configurations and are actually hopefully working the same way. Now, a lot of times you'll find when you're actually having problems is somehow Neutron has gotten out of sync with the underlying operating system, and you'll actually see problems within here. You can go in and change these within the net namespace. Usually you're better off actually just deleting out that particular offending router, recreating it, and making sure it creates correctly. You can use these same troubleshooting commands to look inside the namespaces for DHCP, like I spoke about earlier, to make sure that your your instances are getting IPs addressed to them. So there are many other things that we can talk about with troubleshooting, but that kind of gave you a flavor for what kind of troubleshooting commands exist and how you can walk from the higher level constructs within OpenStack and then trace them down actually into the Linux operating system. And while that's great for actually fighting fires and doing troubleshooting, hopefully you actually spend more of your time where the cloud is simply operating well and you want to be able to actually monitor it. And so let's talk a little bit about monitoring solutions that you can put in for your OpenStack cloud. Now, the first thing to realize is metering is not really monitoring. So a lot of people talk about Ceilometer, which is the metering and telemetry package for OpenStack. And while Ceilometer does some things very well, and that is metering the usage by users of your cloud, it is not really a monitoring solution. It's really a metering and telemetry solution. As a system administrator or operator of your cloud, you really need to have a normal monitoring system, which probably has several components in it. In addition, Horizon isn't really your monitoring solution either. Horizon does give you an admin section, which allows you to do some administrative commands, and actually a fair number of them now with the new Icehouse update, but it is not stateful. There is no history there. There is no ability to go back in time and find out what it looked like when it was running well versus today. It won't allow you to do any kind of capacity planning or many of those kind of things. And so when I talk about monitoring to most people, I have them look back at the ISO standard called FCAPS. Your monitoring solutions need to monitor for faults, configuration, accounting, performance of your cloud, as well as security. And now, not every solution is going to be able to do every one of those. You need to think about how your monitoring solution or group of solutions is going to provide you that level of view across your cloud. Likewise, you need to be instrumented at multiple levels here. So you still need to be able to do some level of hardware and operating system monitoring. You need to be able to monitor at the OpenStack level. And ideally for your customers, you'd like to be able to do some level of monitoring at the VM. Now, for public clouds, many times this is actually, VM monitoring is actually left to the client to do, and they can bring their own tools. In the enterprise, though, oftentimes many of your customers are more used to a traditional IT, where IT may monitor that for them or at least give them the tools to monitor that. And so in the enterprise and the private cloud, you may want to actually provide something that gives them VM monitoring for the user. The last thing, all of your monitoring needs to be across all elements and processes. So you do need to monitor everything, just like you need to have everything under configuration management. And so let's look at a few of the things that we can look for here within the monitoring realm. So operating system monitoring, I think most people are probably very good at this because they've been in the enterprise for a while. We need to have the same set of information as you're going to have for any other systems out there. CPU utilization, memory utilization, what's the availability of the system, and things like that. In addition, we do need to step up a bit. Because we actually know what processes need to be running, we need to make sure that we're pulling process-level information and process-level availability. And that's from everything from the infrastructure pieces of OpenStack, like RabbitMQ and databases, all the way to the custom pieces of OpenStack processes, like I showed you on the third slide here, where all the processes are there. And ideally, the one thing that's probably different than with a private cloud than perhaps with your enterprise, normal enterprise IT, is because of the scale, many times we want to rely on the host sending back information to us rather than us having to ping or go out and query the host every time. In general, that doesn't scale well, and as we start to get to hundreds of machines, you actually end up with scalability problems on your monitoring platforms. In addition, ideally, we're going to have some level of APIs for this monitoring and a strong discovery component for it. And the reason there is, in general, you will be bringing in new machines, and a fair amount of them, perhaps racks at a time, and sometimes machines will leave. This is probably a little bit different than enterprise IT also, and it tends to be much more dynamic. And so having strong discovery, or at least an API to write to be able to initiate monitoring as well as turn off monitoring, can be extremely important for you. So there's a couple different solutions which are out there which we see a lot in the community. Obviously, one of them is Nagios. It's probably the most prevalent open source monitoring solution out there. It's installed as a part of many of the OpenStack distributions, for example, like part of Red Hat RDO. It's fairly easy to install, and usage is fairly easy. You'll get presented groups of hosts, and you'll get your general red, yellow, green status about whether they're available or not, as well as have any other kind of problems there. There is the ability to add an API to it. However, that is an add-on module. And so that's a little bit more difficult than perhaps some of the other things that are out there. Now, having said that, because Nagios is so widely used, there actually is an OpenStack plugin available for it. which gives you a number of service checks kind of out of the box. And so today those service checks include checking to make sure that Glance and Glance API is up, that Keystone is actually authenticating, that Nova API is actually answering back to you, as well as some checks for Swift around their API and dispersion stats. The plugin is extremely easy to install. It's part of most people's operating system distro. However, it really just covers some really basic levels and does not cover all of the OpenStack programs that you probably want to monitor. Another option would be Zabbix. And so this is the Zabbix console. In general, we've tended to use Zabbix more often, mainly because it has a very strong API and discovery modes. It's an open source tool also that we've been used at several large service providers. And it tends to have what's called a template that we can apply to the host groups. And these templates are things that we can then monitor those host groups against. So for example, in the Zabbix templates, we create templates for each type of server that's out there, whether they're compute nodes or controllers or the object servers within Swift or whatever. And then we can apply those templates to monitor particular items on those machines. Each template checks the processes are running, as well as the configuration management is running on all of them. One of the things we found is it's easy to find one server that's not using the configuration management, so we make sure that we check there also. We make sure that all of these checks are actually, as many as possible, are done local on each machine, and then they're only sending back the data to the Zabbix server of when the things are not working for us. This aids in scalability without having to go out and pull every single machine. We also make sure that we're actually not just checking the process table that the process is running, but we're actually making sure it's running by running some command against it. So we issue commands against the processes to make sure that we don't have just a hung process. One of the things that we found is, some of the OpenStack processes, as well as some of the queue processes, can hang up under high load. And while they still appear in the process table, they're not actually functioning anymore. So we make sure that we issue a command against them to actually get a response. So for example, something like rabbit, we might do a rabbit control just to show topics or something like that within the queue and make sure it's actually functioning. And then we make sure that all of the nodes also get the default OS template to be able to run things like CPU utilization and memory. And then any alerts get set up for PagerDuty or whatever alerting system that we have out there. And we found this to be very powerful for us with a minimum amount of overhead for most of our machines. Now, the management tools that I've talked about kind of give you the OS level, and they're heavily focused on providing availability information and occasionally some level of performance information. However, what we found is it really doesn't give us enough information up the stack to be able to look into how OpenStack is actually performing and how some of the more detailed things around OpenStack would work. And for that, we rely extremely heavily on log management. So log management is the ability to centralize all of the OpenStack logs and syslogs to a central place and then be able to run either some amount of queries or analytics over it to actually generate information. We use it for much more than just error viewing and querying for errors within the logs. However, it is absolutely essential for doing that. It's really, for us, the primary source of OpenStack data. It's useful for finding simple OpenStack bugs, which may be running in the code, understanding event timings, so for example, how long it takes us to spin up a new VM, visualizing cluster level statistics, like being able to tell you how many VMs are running across my entire number of hypervisors, as well as creating some dashboards to be able to bring all that information together in one place. Now, bringing all of that logs together can be challenging to be able to store, query, and then interpret all of that data. And so we do use tools to actually do that. Remember that your OpenStack clusters can generate gigabytes of information or logs per day, especially if you turn on verbose mode. So you do need to use some dedicated tools and data stores for that. And also remember, those logs may be required, depending on what industry you're in, for compliance, legal, or audit reasons. And so I find log management a must for everyone. One of the probably premier tools to use on this is called Splunk. It's a commercial log management tool. As you can see on the right-hand side, it allows me to do visualization, ad hoc queries into my code, post-processing, and there's a whole bunch of different add-ons that I can provide there. It also allows me to set up easy dashboards. So on the right-hand side, for example, is a dashboard that we use within our laboratory cloud in our data center, which shows us things that we can't pull out from some of the other things which are out there, which I'll talk about here in a second. Splunk, being a commercial tool, is a relatively easy installer, and as log management tools go, it actually has a very nice UI. Having said that, it can be somewhat expensive. It is a commercial tool, and so many people will look for an open source alternative. The alternative we actually tend to use more often with many of our clients is a combination of tools called Logstash, Kibana, and Elasticsearch. Logstash is a log parsing tool. So if you push and point all of your logs to a central machine, Logstash will go in and actually parse those logs for you to make them easily searchable. Elasticsearch is a kind of a NoSQL database/data store, which allows you to store all of those logs. And then Kibana is an interface over the top of it that you see down on the right-hand side of this, which actually allows you to do query and visualization of all those logs. All of these are open source and provided by the Elasticsearch company. It is a little bit more complicated to set up, especially to be able to parse the logs correctly, but it does provide you a free tool. It's a very good tool that scales very well, and it provides you many of the same features that you're going to find in Splunk, obviously at zero cost. There is a very active community around it, and it's a tool that we suggest to many of our clients that are out there. Now, once you have the logs, what do you actually want to be able to pull out of them? And that's an important part here. And so today, these are things that we pull out of our logs. CPU instances by hypervisor. So while it's great to know the total number of CPUs being used in your cluster versus the total that is accessible, we also like to find out how many CPUs are actually being used on each hypervisor in like a stacked bar chart over time, just to find out how good is the scheduler working about putting instances in the correct places. We'll do things like look and make sure we have graphs of all of our VM spawns, or when we start up VMs, the number of successes and failures that we have, and then be able to drill in and actually look at the logs for any one of the failures. How long it takes us to spawn a new instance. The top users of VMs and vCPUs within our cloud. All of those kind of things we can pull out of the logs with a little bit of parsing and using either one of the Splunk or Kibana tools. There's a bunch of other things that we'll look at also here. So, for example, I list here authentication, the number of tokens that are generated, the number of failed authentications that are there. I'll use the ad hoc query part to search for errors also. Any one of the errors that you see within OpenStack start with a capital ERR. And so it's fairly easy to set up a recurring search for that, and you can see any one of the errors or stack traces within OpenStack to find out if it's a known bug or if it's a bug that you actually should be filing to get fixed. In addition, the logs also give you a fair amount of information about which processes have actually stopped. Things which are no longer logging, chances are probably no longer running correctly. And so we also then use that as a secondary source of information about whether processes are actually running or not. Now, those just scratching the surface of the things that we use log data for. We use log data across all kinds of areas. In fact, We even create topologies and pictures of our cloud via the log data. There's really very little limits to the amount of things that you can do with the log data, especially with the voluminous amount of logs which come out of OpenStack. I think over time, and as you'll see next week with the OpenStack Summit, there'll be a number of companies that will be announcing different tools around monitoring. And I think you'll see actually some very dedicated OpenStack monitoring and management solutions over the next week or two. And so for the final slide here within the presentation, I always make sure that any of my monitoring solutions have some kind of what I call a canary script. OpenStack is a very complicated system with a lot of interdependencies. Your VMs can stop or not boot for any number of reasons across a number of different systems. And so while it's great to know that all the processes are running, it is great to know that all the systems are up, at the end of the day, most of your customers are really concerned about, are my VMs going to spin up? So can I create a new VM? Or are my VMs actually running today? And so we've created a number of what we call canary scripts to make sure that this is always working. And so it's the highest level check for our cloud is, can we spin up a new VM and do things with it? So we've written custom scripts that start up a VM, goes in and does what we think are normal things to do with the VM. Attach block storage to it, assign an IP address, ping the outside world, and then usually just terminates. And we make sure we log all of this into our log management solution and end up putting it on some kind of cron job where it runs every 5 to 15 minutes, depending on where we think we need it for checking availability all the way through here. We also make sure that the scripts can be run interactively, so that any time we come up and we actually hear that someone's having problems creating a new VM, we can run this interactively very quickly to find out whether or not they're just having problems or if the actual problem is with the cloud itself. Usually we leave this to be written by the sites because every one of the sites will have a different level of services and they'll have a different level of things that they want to be able to test on every check. However, this is something where we actually have some of these up at GitHub, and we can certainly share with you some of the examples of these. They're very simple scripts usually, but being able to run this gives you some level of comfort that your cloud is actually up and running and actually has some level of integration tests to make sure it's going. So with that, we're at kind of the end of the time without having saving sometimes for questions here. You will see that there is I think I can press this out. Oops. I will send out, this is the URL where you can pull down the slides. The slides do have some additional slides in them. And you may want to go through those. It does give you some additional things about troubleshooting VM backing stores and some other things that are in there.